YouTube channel. So let's continue with the part 3 of the molecular orbital theory, which is the bond order. So why we need to determine the bond order? Because we want to determine the existence of the molecules. Alright, so with the bond order, in order to determine the bond order, we need to have a formula. So what is the bond order? The formula here is equal to half times number of electrons in bonding MO minus with the number of electrons in anti-bonding MOs. So these examples for the bond order. For the first one, okay, let's calculate for the first one, which is the H2 plus. So the bond order of this is, alright, sorry. Okay, so the formula here is half times with the number of electrons in bonding. So bonding is the sigma here. 1 minus number of electrons in anti-bonding MOs. So we have a we have a 0 electron here, and the answer is 0.5. Okay, and then for this one, the bond order is half times 2 minus 0 equal to 1. And this one, okay, for the He2 plus, this is half times 2 minus 1. This is 0.5, while for this one is half times 2 minus 2 equals to 0. Okay, so let's check. The bond order of first one is half, second one is 1, second one is half, and the last one equals to 0. Okay, so anything the bond order with anything 0.5 or 0.5 will usually, anything with a 0.5, okay, this is the bond order, usually will show us the what we call a radical. Okay, and for example, let's say here we have a 0.5, okay, or half. This one usually 0.5 bond order is very weak, but we still consider this one as a bond. Okay, 0.5 bond order. But what happens if we have the bond order equals to 0? It means that this molecule here, He2, does not exist. Okay, because there is no bond exists between the helium. Okay, so the helium with helium here does not exist. Okay, alright, and then this is example for the molecular orbital diagram for the hydrogen. So from this one, okay, we can determine the bond order of the hydrogen. So the bond order for hydrogen equals to 1. So if you draw the Lewis structure for hydrogen, H and also H, we have a single bond between hydrogen here and also here. So we have 1 sigma or 1 bond order. And another one, we have a helium 2 plus and also He2. Alright, and then so the bond order for this one, because this is a radical, usually it will give us with the bond order of 0.5, while for the second one here, helium 2, alright, and then the helium 2 we have the bond order of 0. Okay, so this one is exists as a radical, while this one does not exist. Okay, and then other than that, okay, this is a sample problem, and you need to determine the, or you need to draw the molecular orbital diagrams, okay, for the H2 plus and also H2 minus. Alright, and then you need to determine their bond order. Alright, so the solution here, okay, so you need to draw first the molecular orbital diagram. So you need to have this is for H2 plus. Okay, so we have the atomic orbital AO of the hydrogen with 1 electron. Okay, this is 1s1. While for the second one, because we want to have the H2 plus, okay, so this one, this hydrogen removes its 1 electron, okay, here with and it becomes 1s0. Okay, and then we have the sigma and also sigma star, okay, with only 1 electron, okay, 1 electron in this sigma 1s. Okay, alright, so the bond order for this one will become 0.5, and it does exist. Okay, it does exist for this compound. What about for this here, H2 minus? Okay, alright, so we have an extra electron in this molecule. Okay, so this is 1s1 and an extra one here is 1s2. alright, and then you fill up the electron because we have 1 here and 2 here, so we need to have 3 at the molecular orbital of the H2 minus. Okay, so the bond order is also half, so it means that this H2 minus does exist. Okay, alright, so what about the electron configuration? The electron configuration, we start from the bottom to the top. Okay, so we have, this is where you need to refer to the molecular orbital. Okay, molecular orbital configuration. So we start with a sigma 1s 1 electron, and then we have sigma star 1s 0. Okay, and what about the second one? The electron configuration here is sigma 1s 2 because we have 2 electrons, and sigma followed by sigma star 1s 1. Okay, so here this is the electron configuration for H2 minus. Okay, so what about these two? Okay, what are the electron configurations for both, and they exist? Okay, so let's look at the first one. Okay, the electron configuration for this one, we start from the bottom to the top, and we only refer to the molecular orbital, not the atomic orbital. Okay, so at the center here, so the electron configuration for this one is sigma 1s 2, and then followed by sigma star 1s 1. Okay, the bond order is half, so this one exists. Okay, while for the second one, helium 2, okay, what is the electron configuration? Sigma 1s 2 and sigma star 1s 2. Okay, so the bond order is 0, so it means that this compound or this molecule here does not exist. Okay, so that's all for part 3. I'll see you guys in part 4. Okay, so don't forget to like, comment, and also subscribe to my YouTube channel. Okay, so that's all. Bye.